Hello everyone, welcome back to another video. In today's video, we'll be doing something slightly different from our regular content. Basically, I was inspired by the Primeagen and the team over there who made this really nice terminal-based coffee shop. So if I just did SSH terminal.shop, we get this really nice TUI-based shop which you can buy actual coffee from over SSH. So I'll navigate up and down using my Vim keybinds J and K. I can also add things to my cart. See that my cart already has a bunch of items because I've been playing with this. I can hit C for checkout and I can type my name here. I can't type today. Street name, blah blah, right? And hit enter. And there's also validation, and it's just really fancy. So I just wanted to make a really short video, kind of like a hello world, to introduce people to the technologies that terminal.shop uses. And the reason I can do this is because it's open source and you can just dig into their source code. Terminal.shop. Sorry, that's the actual production website. So here, this is the repo where all the source code for terminal.shop is hosted, and you can go dig around if you want to on your own time. But I will do a quick demo on the Hello World app I wanted to create today. This is the app that I've created. It's on the Go package registry, and the reason it's on here is because I made this repo public, and whenever you have a public GitHub repo and you go install something, Go will just add it to its registry. So this is a very simple server that I stole from a friend's Minecraft server, and it's got Go installed. So in order to install this demo app, all I gotta do is grab this URL here from my basic wish app, which is essentially just this part of the URL. We do go install, put that in. We'll say version 0.0.1, and that's because I tagged the current commit with that version number. If I hit enter, Go will install that, and it doesn't say anything because I've installed this before off screen. But what happens is it gets cached. And where does it get cached to? Well, everything happens inside of the Go directory in path. So if you want to know where it is, if you're not using Linux, you can just search Go path, and this is where the Go folder will be. Just read this blog, you will be able to figure it out. But I should really start using ls-lah because this is bash and it's not fish. But here you see bin and package, and inside a package you'll have all the cached materials. But because we did go install and this URL, the stuff that we want is inside of bin, which is the binaries folder, and contains our binary here called basic wish app. That's the compiled binary, so it's an executable. I just remove everything else. Remove .sh because I ran this demo once off screen. So yeah, so now we only have our executable. If I do a / basic wish app, you'll see that our server is now starting, and if I come over to my SSH terminal, I can do an SSH, and because this is the host name, I'll just copy that and paste it in. Yeah, I've done this before, so I gotta remove known hosts. Let's run this, hit yes, and this is our very basic hello world. If I typed hello, hit enter, right? And now I will blur out my IP addresses, but you'll see all the connection logs. If I do ls or I do cat output.txt, you'll see that whatever you typed will end up in this server. So first things first is to set up version control. If you have a GitHub account and you want to publish this project so that Go install can find it publicly, you would make this repository public. And I won't set up Git because I've done it and I don't want to waste time. So I'm going to come in here and I will initialize this. I have this empty folder first of all. Well, ignore the .git and git ignores. I will actually just also remove the SSH folder so we have a clean slate. So what you do is do go mod init and then initialize this folder as a go module. And this argument here is the name and the path to your project, and in this case this is the path to mine. So I'll copy and paste that there. What it's done is it's created a go.mod file. If I cat that, you'll be able to see it's very simple. So then I'll open this in NeoVim, and I will create the entry point now for this Go app. Now the entry point of a typical Go app is in a package called main, and inside that package it's looking for a function called main. It doesn't really matter what the name of the file is, but what's important is you have to have package main and func main. And as a simple demonstration, I can do an import fmt and do fmt.println foobar and go to my CLI. If I do go run dot, see that foobar has been run. So let's get started by making a very simple text input show up in the terminal. And what you can do is go to the charmbracelet bubbletea repo and read the quick start. But I will just come over and play this video so you can see what this looks like, and go over to the example code and grab the imports. Then I'm going to go back to my NeoVim and let's make this nice looking. Paste that here, close the bracket, remove that extra thing, and let's go ahead and temporarily disable my auto formatter. Save this, and it's going to give us warnings. We'll ignore that because we have to go and do go mod tidy. And what this does is it'll detect that there are 2 new imports that we haven't added before, and it'll go and download those packages into the Go cache. So the way it works is that because you've imported bubbletea under this alias of t, we can now do t.newProgram to create a new program, and what this returns is a pointer to a t.program structure. So I do p, assign it to t.newProgram, and now we can do p.run. And this runs the program and it returns 2 things. It returns a t.model and an error. So we'll ignore the t.model for now. So we'll say if underscore and then error and set that equal to p.run. And we'll say if error not equal to nil, which means there is an error, we'll do log.fatal error. So you'll notice that here we have an error, and the error is because when you call t.newProgram, it expects you to pass in a model. So what is a model? A model is how we keep track of the state of the entire app. So bubbletea is built on the Elm architecture. That means you have a model, which is the state of the entire app, and then you'll have a function which converts the model into an output. So anytime you have an event, you would change and update the model, and then the view function will read that change from the model, and then it'll print the new output to the screen in the terminal. Okay, so for this part, you're going to need some functional understanding on how methods work in Go, and if you don't, you can just go to this website here and go to the methods and interfaces section and read all of these. It's a really nice guide that you can just follow. And what we'll do is we'll create here a type of model. Now, the model could be any type. It could be an int, it could be an array of integers, and it could be a struct, which is what most people use because it makes the most sense and it's the most flexible. But essentially, what's most important is that this model has to follow an interface. And let me just create that real quick. So that what that means is we need to have 3 functions or 3 methods that are attached to this model. And these specifications are defined in the charmbracelet bubbletea source code. So what I'll do now first is I'll make a constructor called initial model, and this returns a model type. And for now, I'll just return an empty model with nothing in it. And I'll pass this model in to the new program. And earlier I was talking about interfaces. And here you can see why that's important, because without any other methods on this model, it's just an empty struct, we get this issue here in the linter. It says invalid interface. It expects this init method. It also expects, let's see, yeah, a bunch. It's hard to read this output. So I'll just verbally tell you that it expects 3 methods, and because we don't have those 3, it's causing issues. So first, let's make the first one. Now this is going to be a method on the model. So I'll make mmodel, and it's called init. This is the initialize method, and it returns a t.command. So I'll just return nil for now. This is an empty command, which basically just tells bubbletea to do nothing. And we'll never run this function at any point ourselves, because this is something that t runs for us. When you do program.run, in the background T will call init. It'll call the next function too, which is called update. Right, and we'll also never directly call this at any point. So update takes in a message which is of type t.msg, and it returns 2 items. So let me just jump over here. So it returns first of all, it returns a model. So t.model. It also returns t.command. So the reason why it returns t.model is because this is not a pointer receiver, as you'll notice. That means any changes we make to this model will be not persisted outside of this function scope because it's passed by copy. And the way we update this model is by returning a new model that is based on the old model with the changes, and bubbletea will intercept this model and deal with it however they want. So it's abstracted away from us. And if you come from the world of React, this will feel familiar because this is kind of like state updates where state has to be immutable. So in some ways, this is immutable, but we can change it and then return it, which will become the updated model. And t.command, I'll explain this in a second. Don't worry about that for now. So what I'll do is I'll return just the same model, which means we won't do anything to our messages. So when a message gets sent, this update method will be called with that message, and we'll just ignore the message for now and directly return the same model as before. And command, as usual, I'll just return nil and ignore the error for now because we have to implement our third method on model, which is called view. So view returns a string, which is what ends up on the terminal. And it takes in the model, the model which is from this receiver over here. So for now, I'll just return foo bar. So if I save this, you'll see that now all the errors are resolved. So now let's see if we've got something functional that we can run. So I'll do go run dot, and the reason why this works is because we have main.go in this directory, and go will look for that. So when you do go run dot, you see foo bar appear in the terminal. However, this is quite uninteresting because if I type any key on my keyboard, nothing happens, and that's because our view function creates a string. It's supposed to create a string based on the model state, but it's not. It's just creating a hard-coded string and returning that. And this is kind of like our event handler, which listens for events, which come in the form of t.message, but we're not really doing anything with those events either. So this is really dangerous because now if I come back to my program, if I try to stop it using Control-C, nothing happens. If I type Q, nothing happens. So really the only way for me to stop this program now is to open up htop. And if I search for go run, that's my process ID. And I can just kill it by sending a sig term. And now the program stopped and we can clear the terminal. So in order to fix that issue, we will come into this update function and we will listen for a very specific event. And when that event is called, we will return the model and we'll return t.quit in the command. So this is how we tell t that we want to stop running the app. And this is an import. So I will just first comment this out. And I will have an if statement here that does kind of like a type assertion, a typecasting. So we'll do message and we'll try to cast it to key.message type. And if it worked, we will run this command. We'll return the quit command. If it didn't work, then we will just go as usual. So what I'll do is assign this, well, this returns 2 items. The first is the value of the typecast, and the second if it worked, and I'll set it to OK. And if OK is true, then I will run whatever is in here. If it's not, then I will skip. And value will contain our typecasted object, which has a bunch of properties, but the one I'm interested in is the string method, which returns a string representation for a key message. So this string function will return to us whatever key was pressed, but I don't know what the key is for Control-C, what the string representation is, because that's something that the bubbletea developers have chosen. Well, if I was making a React app or a Python app, I would use the debugger, or I would use console.log or print to print out the string to the console to kind of see what's getting set here. But because our standard out is being occupied obviously by the main app, we can't really do that. So instead I'll write this out to a file which I can read from the side. So what I'll do is assign this to a variable called key, assign that there, and I'll use os.writeFile. So os.writeFile takes in the file name, which I'll name output.log. The second argument is the data. The data is expected to be an array of bytes, but I want to write a string, so I'll just do a typecast like this and say key. And then I will have to give a file permission, and because I just googled this example, they gave 0644, and what that means is it's an octal representation of the POSIX file modes. You can read up on that. I'm not going to show that here, but basically what 0644 is read and write for user, which is the owner, and read for the group and other users that aren't the current user. So I'll just put 0644 in here. If I save this, I can come in here and do go run dot, and I can do a control C. I've just done control C, but nothing visually happened, but that's all right. So I'll come in here and I'll kill this program. But what you'll notice is if I go back to my NeoVim, you'll see that a new file has been created called output.log. Go in there, you'll see that that is our result. So now I know to compare my string to control plus C. I'll just copy that and come over here and say if key, sorry, it should be down here. So just if key equals to control C, then return them, comma quit. And of course this has to be in quotations, so let's do that. Okay, let's see if this worked. I'm going to come in here and go run dot, hit enter. If I do control C, it stops, so that's perfect. So now that we can finally quit our application, I want to make it so that the view function will return a string which is not hard-coded, which is something that is based on the current state of the model. So that means I'll come into the model structure and I'll introduce a new property here called key. And key will be a string, or let's just say payload, for example, so it's not as confusing. And here on line 25, instead of returning foo bar, I want to return payload. Sorry, sorry, it should be m.payload. So on line 21, if I don't specify anything in this model kind of constructor, then it'll just create a struct with the payload of the default value. And the default value for strings are just empty strings. So I'll not do that. Instead, I'll just say default value here, or yeah, default value works. And now in my update, instead of just listening for control C, I will have other cases here. So if it's control C, then I want to quit. If it's not control C, then what I want to do is return, or just say model.payload equals to key. And we will return it down here. So it will set, yes, we are changing the model object, which is passed by copy, but because we are returning the new copy, bubbletea will know to use this new copy. And yeah, so this looks good. So what I expect is when whatever key I type will show up in the terminal. So let's do a go run dot. So default value shows up. If I do a shift A, that's a capital A. If I do A, that's regular A. Quick, brown, fox, I can do control C, and that worked. I can do C, enter, underscore, equals, backspace, period, and question mark. So that's perfect. Now, the great thing about bubbletea is its ecosystem of pre-built components. So there's this repo called Bubbles. If you go and look at it, you'll have a bunch of pre-made components that you can use, kind of like a component library. And I just want to show you the very basic text input component. Now, you can go and look at the example code and see how it, see the default quick start that bubbletea or charmbracelet has provided. But here, I'll just very quickly show you how it works. So if I go to my main file and I can uncomment this, so now we have access to this bubble called text input, and they basically call their bubbles, they call their UI components bubbles. So what I'll do is I'll come into the model here, and I will specify that, hey, instead of payload, I want to have a text input. Its type of text input dot model. So what this means is that this text input object will have its own update function, its own view method, its own init method. And what I can do here is in the view, instead of returning m.payload, I can return m.ti.view. And this will basically return a string always, but the string is something that comes from the text input component, and it won't come from us. In fact, we can extend this by setting output to be equal to m.ti.view, and put that here in output, and then we can do format.sprintf for a formatted string, and we can say that the string will be what is your name ? And 2 new lines, and then we want $v here. So if you don't know what that is, just go to go package and then go to /standard, right, and look for FMT. This is the Go built-in standard library, and these are the verbs that you can use. If it's too small, let me zoom in. And %v, not ampersand. Did I say ampersand before? Yeah, %v is the value in default format, and that's good enough for our use case. And this will get replaced by this over here, which is a string. That's what it returns. And yeah, so what I'll do is save this so that format gets added here by my auto formatter in the import statements. And then here in the model, of course, our initial model will not have string as the default value because now it's a type of text input dot model. What I'll do is I will create TI here. We'll say text input dot new, and we'll return that here. And also this is giving us issues because m.payload is undefined. Yeah, so we can take that out. We're no longer using our own payload. We're using text input. So text input will store the state. We don't need to store any state here because that's handled and abstracted away by this bubble. So I'm thinking that this should work, and let's come over here. Oh yeah, this wouldn't work because we're getting our key inputs, key events, not key inputs. We're getting events here, but we're not passing the events into our text input model. So whenever there's an update, the text input component doesn't know that there's been an update. So we have to kind of bind it by doing this. So what I'll do is m.ti equals to m.ti.update message, and what this does is it returns a model, a new model, and a command. So I have to do command, and this has to be var command t.command. So what I've done here is I'm updating the text inputs model using m.ti.update, and it returns to us, because remember it's immutable, it returns to us a new model which we assign into m.ti, and then when we return m, this new model will have the updated text input model inside of it, and then whatever command it gives to us, we will just pass it forward. We'll return it like this. So bubbletea will take whatever command that this update gives and just run with it. And the reason why I had to create this var up here is because if not, I would have had to do this, which wouldn't work because m.ti is an existing variable. I'm not trying to assign it to a new variable here. So I have to make it consistent and make it a new variable declaration up here. So let's see if this would work by doing go run dot. And yeah, what is your name? And I can start typing, but you'll see that nothing happens. And the reason nothing happens is because of the way text inputs are built. So the bubbletea team, when they were creating the text input, they figured that some people might want to have more than one text input, right? You probably want to have 5 text inputs or 2, one for your username, one for your password. And we wanted to just be able to loop through every text input and just send the update events to all of them. And only the one in focus should update, because otherwise you'd have all the text inputs typing out everything. So if you typed ABC, both the username and the password inputs would have ABC appear, and that's not ideal. So we only want one of them to be focused. And so here what I'll do is I'll have to do ti.focus. And what this does is it tells this text input to be, basically I'm telling the text input that, hey, you're the one in focus. So please, when you receive messages in your update function, please act on them. And if I Control C, and if I ran this again, now I can type here. And there are a bunch of very fancy things you can do here. For example, I'll just give you a very quick one, which is we can set the placeholder to be equal to John Appleseed, for example. And if I save this and rerun this, notice that the placeholder didn't fully work, only J came out because we have to set the width of this text input. So what that looks like is I have to do ti.width equals to 20, for example. Now if I restarted this, you have that nice placeholder. When I start typing, it goes away. There's just one thing I want to fix before moving on from this section, and that is, watch, when I run the app, the cursor starts off by being a static cursor. It's not blinking, but as soon as I start typing, now it's blinking, right? If I delete that, it's blinking. So in order to make this cursor begin blinking from the very start instead of blinking after I've sent an update event, what I do is I would come here and finally make use of this init method, and I'll return text input dot blink. So this is a command that comes from the text input bubble import, and if I run this now, you'll see that it begins blinking right from the start. So that's wonderful. So we're nearly there. I just want to do one more thing here, two more things here. I want to make this full screen. So if I do go run dot, I want this to take over the entire screen, kind of like what terminal.shop has, right? If I do terminal.shop, you'll see that this is a full screen app and it takes over the entire screen. And the next thing I want to do is I want to make it save to a file. When I hit enter, right now nothing happens, but I want it to save to a file, whatever I've typed into the text input. So I'll actually do that before I do the full screen thing because we're already here. So what I'll do is I'll say if key equals to enter, and if key equals to enter, of course I want to quit, right? Because that's the end. We've done everything we wanted to do in this program. But here I'll have to save to file and then quit. So I'll first do os.write file, kind of like what we had before. And the first argument is output.log. The second argument is the payload data. And the third argument is the file permission. So what do I put in here? How do I get the value inside of the text input? Well, it's as simple as doing m.ti.value, and this function returns the value of the text input. Wonderful. So if I just make sure that output.log has nothing of consequence, and then now if I do go run dot, I can type in hey there or foo bar baz, hit enter. Notice that the app has quit. If I come to my output log and I refresh this, foo bar baz appears. Wonderful. And to make it full screen, go to the examples. You'll figure it out by going to main.go. See that they have, this is the only important thing in this entire example, is t.with alt screen. So these are program arguments, which if you remember, were optional from the start. So I never provided any. So here now, finally, let's just copy this and go to neovan. And let's go to our the run function, or the main function, and provide that as a program argument. So now if I go back here and do go run dot, or I should do something like ls first just to dirty the screen. Now if I do go run dot, see that it takes over the entire screen. I can type something here like hello world, hit enter. We go back to our main screen, and if I do cat output.log, hello world. All right, that's enough bubble tea for the day. Now I'm going to move on to the last part, which is serving this app over SSH. Say that you've built out the entire application and you just want to allow users to access your thing from over the internet. Instead of through a website, it should be through SSH. So charmbracelet has came up with this very nice tool called Wish, and it handles all the SSH stuff for you in the backend, and it abstracts all that away from you, so you don't have to worry about security issues or having to create new users every time someone tries to connect over SSH, or restricting the shell so that users don't accidentally gain shell access or root access to your server computer, because that would be very detrimental. So all that's handled for you. You just gotta go to Wish and then go look for the example. Let's go to bubbletea application example. So there it is. So Wish provides you with a bunch of middlewares you can use, but I'm interested in the bubbletea middleware. So this is the example that the team has provided to us to use bubbletea apps inside of Wish. And what I'll do is just copy this entire file. I'll rename our old file to main.backup. I'll make a new file called main.go, and I'll paste the example in here. So the relevant configuration options are over here. If you want the default SSH port to be used, then you use port 22. If you want this to be deployed in production, make sure you change this away from localhost to 0.0.0.0, because that's how you tell the computer to listen on all interfaces. Otherwise, localhost is good for development. And here we're telling we're telling Wish that we want the SSH keys to be stored in this path, and then everything else we can leave as is. These are basically just Go routines which run parallel. It's kind of like multi-threading, but we won't dive into the details there. If you want to study this, go to the Go book or the tour of Go. But what's important to us is this bubbletea middleware over here. We're specifying a function called thandler, which returns two items. We return the t.model and the t.program option. So what I'll do here is clean up the comments because it's kind of messy, and I'll add a barrier here or a divider here. So everything below the divider we will change to fit our app. Everything above we can just leave it as is directly from the example, right? Except for the constants over there. So here what thandler does is it returns the bubbletea model and the program options, and basically everything in your bubbletea app is contained within the model. Your view function, your update, your init, everything is in here. So that's all that bubbletea needs really to run your app. And we before we would run our app in our main function by using t.newProgram, and we pass in the model and the program options, right? So in a Wish application, you don't call t.newProgram and p.run. Instead, you simply pass in the model and the program options to the middleware through this function, right? Because this function returns these things to the middleware, and the middleware will do all of the hard work of handling your program, running the program and stopping the program and all that. So what I'll do is, because I've already written my init, update, and view functions, and I've also written my model, I will delete all of that. I don't need any of that. I'll just go and copy this from our old file. So that's our model, our init, our view, and I'll copy that and just paste it down here. So we get a bunch of errors because we have to import text input. If I do a save, we should now have auto imports. So we've imported text input. Those errors are now gone. We still have a bunch of errors here. Well, here we're returning model, and the model is being redefined over here. But remember, I created this initial model function to return us the initial model, so we don't really need this anymore. And I don't care about the background color because this is a very simple example. I don't care about text styles. I don't have any styling, which means I don't need the renderer, which means I don't need any of these. The reason why you would have a PTY here is if you wanted to get information about the client's terminal session. So maybe the type of terminal, the terminal's width, the terminal's height, the terminal's color scheme. Is it dark? Is it light? I don't care about any of that in this example, so I'll just simply call s.pty from the example without taking any of the return values. And here model will be initial model. And that really should be everything that we need. Everything down here is from the file that we have created before, and everything above is copy pasted from the example. So now if I go and do a go run dot, well, we can't bind to port 22 because that's a protected port on macOS. So what I can do is change port 22 to port 3000. And now if I run the server again, it will run, and I can do SSH localhost port 3000. So there it is, our very beautiful app. I can make this big. We can type Steve Jobs, hit enter. Our connection gets terminated, and that's because, remember, we have that t.quit or t.quit, right? This is what causes our client to disconnect. And you can look at the logs. The logs will also show that I've connected and disconnected. Now, if I can't do Control-C for some reason on the server, so what I'll do is, let's see if Control-C works on SSH, right? So that does, it just doesn't work on the server. I can't quit the server. So what I'll do is list open files and look for whatever process is running on port 3000, and I will send a kill signal. So it's killed our server. Now, if I cat output.log, I will see that Steve Jobs is indeed inside of that file. So with that, we have successfully created whatever we had in the start of this video, and I will see you in the next one.